Today, we will be taking notes on average rate of change. When you hear the words average rate of change, you should immediately be thinking slope, which we learned about in Algebra 1 and in Algebra 2. And as a quick refresher, the formula for slope is always rise over run. And rise is always going to be the change in our y values, and run is always going to be change in our x values. So then the formula is y2 minus y1 over x2 minus x1. Average rate of change questions typically present you with two pieces of information. They give you the equation, which I've highlighted here in blue, and they also present you with the interval, which I've highlighted here in green. So one key piece of information that you need to keep in your head is that the interval given is always going to be x values. So if they've given us our x values and if they've given us our equation, the piece of information that we're still missing to find our average rate of change is our y values. So as you remember, when you're evaluating functions, if we plug in this x value and this x value into our equation, we should get the y values that we need to find our slope. So let's go ahead and do that. So I'm going to start with f of -2. So we're going to plug in -2 for all of our x's. And here I'm going to end up with negative on the outside. The inside becomes -8 plus 3 times -2 is -6. Now we're going to clean this up. And I get +8 minus 6. So we know f of -2 is equal to 2. I'm going to zoom out a little. We get the other x value, f of -1, is equal to, and again, replacing all of my x values with -1. So here I'm going to get -1 still inside my parentheses, and here I'm going to get -1 times 3 is -3. We're going to clean this up, 1 minus 3. So f of -1 is equal to -2. Now that I have both of my y values that have a matching x value, I can go ahead and plug in this information into the formula above to get what our rate of change is. So I'm just going to label my x's as x1 and x2. It technically doesn't matter which one you label as x1 or x2 as long as you make sure to label the matching y value correctly. So I'm just going to say -2 is going to be my x1 and -1 is going to be my x2, which means this is going to be my y1 and this is going to be my y2. So all I did was I labeled my x values as 1 and 2, and then I matched up my corresponding y values. So now I'm going to go ahead and plug that into the formula, which is up here. Let me just copy that and bring it down here. So that we have a reference. This equals y2 is -2 minus y1 is 2 divided by, again, x2 is -1 minus x1, which is -2. So here I'm going to get -2 minus 2 is -4. And then -1, remember when you have a negative being subtracted, it becomes positive. So -1 plus 2 becomes +1. So my answer becomes -4 is my average rate of change. Now I'm going to do the exact same process, but I'm going to give us a new interval So our new interval is from 0 to 1. And again, remember these are our x values. So I'm going to start by plugging these x values into the same equation that's highlighted in blue. I'm going to find my y values, and then I'm going to plug all of that information into the slope formula to get my average rate of change. So this is where I would like you to pause the video, try the problem on your own, and then you can fast forward till the end to see if you got the same answer, or you can watch me work the problem. Okay, so again, I'm going to start by plugging in these x values. F of 0 is equal to negative 0 cubed plus 3 times 0. So then I get 0 plus 0. So f of 0 is equal to 0. Now I'm going to plug in the other x value, which is 1. So negative 1 cubed plus 3 times 1. We solve this out, we get negative 1 plus 3. So f of 1 is equal to 2. Now I'm going to label my x's. Again, I'll keep the first one as x1, the second one as x2. So this becomes y1, this becomes y2. Now I'm going to plug in the equation. So I'll copy it down again from above. And here I get 2 minus 0 divided by 1 minus 0, which is simply just 2 over 1. Final answer is 2. Before we end this video, let's talk about why average rate of change is so important. So here, as you can see, we have the same equation, but for this equation, we have two different rates of change for the two given intervals. On the first interval, the rate of change was -4, and on the second interval, the rate of change was +2. So the reason why rate of change is so important is because a lot of times in pre-calculus and in calculus, you're faced with non-linear equations. So anything that is squiggly, maybe like a quadratic or a cubic or a square root. So average rate of change helps you understand how the equation looks without actually graphing the equation. Let's go ahead and take a look at the graphed equation to see if our intervals match up with how the graph actually looks. So here I have our graph for the equation f of x is equal to negative x cubed plus 3x. And again, these are the intervals that we got. So from -2 to -1, it goes downward by 4, and from 0 to 1, it goes in the positive direction by 2. So let's go ahead and break up our graph to match these intervals. So here's -2, and at -1. And then again, we were looking from 0 to +1. So if we look at our graph here, it does in fact go with a negative slope, very steep in the downward direction. So here we do have a rate of change by -4. And then if we look at the next part of the interval that we examined, here we do have a positive slope that is less steep. So we're going up by 2. And that's rate of change.